Hey guys, this is a video on binary addition, and here I will first discuss the formulas and then I will implement those formulas on a few problems. And I can assure you that by the end of this video you will have no confusion on this topic. So without any further ado, let's get into the video. Firstly, take a look at the disclaimers. So here, when I use n, it would mean any positive number like 1, 2, and 3. And when I do not mention with carry, this is a code word, okay? With carry, understand that I meant no carry is involved. No carry is involved. Okay, now let's get into the formulas. So formula 1 is adding 0 and 0, and here I have not mentioned any carry, so there is no carry involved. Please keep that in mind. So no one bit involved here, so let's say nth bit of string 1 is 0, and also in string 2 is 0. So the nth bit of result would be 0, and 0 means 0. That's very simple. Now formula 2, adding 0 and 1, and here only one bit involved. So let's say nth bit of string 1 is 0 and n bit of string 2 is 1. You can take vice versa if you like. This is just a demonstration. So here again, no carry involved, and so the result, the nth bit of result would be 0 and 1 with no carry is 1. Fair enough. Now the third formula is 1 and 1. You have to add 1 and 1 from the corresponding bits. So there are two 1 bits involved here. So nth bit, of course, of string 1 is 1, nth bit of string 2 is 1. So again, no carries involved. I'm mentioning this every time. So the result, or the nth bit of result, is a 0 with carry. So 0, and there will be a carry that will be in store for the upcoming corresponding bits. Now, the fourth formula is the most crucial one, and sometimes people look at problems, they look at two strings with so many consecutive ones and think, my god, how many carries are there? But there are actually just one carry at a time, and this formula will demonstrate just that. Here it will be carry 1 and 1, but the speciality is there will be a carry from the previous bit. Typing's got a bit slow. Previous bits, or previous consecutive bits if you like. So two ones from two bits, and the carry from the previous bit. So 3 ones are involved here. Carry from the previous bit and the 2 1 bits in the string. So 3 1 bits are involved. So here nth bit of string 1 is 1, nth bit of string 2 is 1, so 2 1s are corresponding bits. And of course the carry from the previous bits of 3 1s, and the result here would be 1, and of course there would be a carry. So spot the difference, guys. In the previous one I said that there would be no carry from the previous bits and there would be 2 1s, and here there is a carry from the previous bit with 2 1s. So, and in this one, where there is no carry from the previous bit, the result is 0 with a carry. And here, where there is a previous bit carry or carry from the previous bit, there is result of 1 with a carry. So spot the difference here, and this will be very crucial in solving the problems. Okay, now let's get into the notes. That's pretty much it for the formulas. And note 1, I'm going to write 2 notes here. What am I doing? 2 notes here. The first one, adding 0 and 1 with carry from previous bit is equivalent, I'm going to write equivalent in short form, equivalent to adding 0 and 0 from 0 and 0. Here it's actually without the first one, and here adding 0 and 0 with carry from previous bits. Previous bits, or the previous, what can I say, it's the previous 2 complementing bits. Okay, corresponding bits, sorry. And the next one is, of course, adding 1 and 1 with carry from previous bits. Remember, it's previous bits. I'm not going to write that anymore. Is equivalent to adding 0 let's say here without. So adding 1 and 1 without carry is equivalent to adding 0 and 1 with carry from previous bits. You would understand this by now. So these are the 2 notes. Read them very carefully and you'll understand, I'm sure. Now let's get into the problem set. Problem 1, we have 2 strings here. Now, of course, I'm sure you guys would know, and if you don't, there's no problem. I'm going to tell you that we solve binary addition from the right, of course. So the rightmost bits are 0 and 0 with no carry, so it's a 0. And then 0 and 1 with no carry from previous bits, so it is going to be 1. And again here, 1 and 0 without carry, of course, is 1. Again, without carry, 0 and 1 is 1. So that was pretty simple. Alright, now problem 2. Now here we can see 1 and 1. So the result would be 0 with carry 1, and with that carry 1 and 0, 1, 2 ones involved, and we know here that it's 0 with a carry, so 0 0 and the 1 carry, 1 and 0 means 1. And last but not the least, here we'll have 1 and 0 without any carry from previous bit, so it's going to be 1 again. That's all for problem 2. Now problem 3, here again from the right, 1 and 1 is 0 with a carry. Again, 1 and 1 with the carry from the previous bit is 3 ones, so the result is 1 with a carry. And here 0 0 with carry from previous bit is 1. And 0 and 1 without any carry from previous bit, 1 again. So that's problem 3 done. Now problem 4 is going to be a 6-bit problem. Again, starting from the right, 1 and 1 means 0 with carry 1, 1 and 1 with carry 1 from previous corresponding bits. So 3 ones, the result is 1 with carry 1. So 0, 1 and carry 1, 2 ones involved again. So remember guys, here it would be 0 with carry 1. Now let's get to the fourth one. So 1 and 1, 0 with a carry, 1 and 0. 1 and 0 with a carry. So 1 and 1 is, the result is 0 with carry 1. So 1 and 1 again here, but this time another carry, so 3 ones, and the result is 1. And we have a carry, and here 1 and 0 with a carry from the previous corresponding bits. So 2 ones results in 0 as we know, and there's nothing else remaining. So for the carry there was an extra 1 to the very left. Just going to give the spaces wide so you guys can understand. Sorry. Okay, that's it for the problems, and I have 2 exercises here. You guys please try them out, and I will drop the answers of the 2 exercises below in the comment section. And that's pretty much it. Guys, please like, subscribe, and feel free to comment down below, and thank you very much.